last speaker is Andrew Stewart, and he is a postdoc at the University of California, Davis in the lab of Steve Luck. And his talk is on data quality metrics to improve EEG/ERP research, the Standardized Measurement Error SME. So whenever you're ready, Andrew.
Hi, everyone. Yeah, I'm glad we could see some cool talks of applications of EEG data. I'm working with Professor Steve Luck at UC Davis, who has done a lot of EEG bootcamp and coordination work of helping people run EEG experiments well. And we wanted to do big meta studies where we take not just data that we'd recorded in our lab, but also look at other recordings and combine them in a meaningful way to try and improve our confidence of the true measures that we were looking at. And we find it was kind of difficult to just put them together elegantly, because examining some of the data subjectively, we could see certainly there was data that was not brilliant and some data that was much easier to integrate. And I think it is the case that labs are going to differ. The exact protocols that people have, the hardware that we're using, and the way that we're training our RAs is going to lead to some amount of variance in the data quality. And especially since this is such tiny signal that we're examining. This is microvolts recorded across the skull, across the skin, which might be sweaty. There's so much environmental noise, even when we're in good conditions. And in order to look at more and more subtle experimental effects, we want reliable and repeatable investigations. We want things with high effect size, which needs both the true effect and good signal to noise ratio. There are many analysis procedures that can improve your signal to noise, perhaps different filtering settings, but necessarily this is going to increase analysis complexity. And so this is going to increase the experimenter degrees of freedom, and so likely greatly reduce the reproducibility. If we're doing things like collaborations or external validation or meta studies, these are things that we as scientists can do that will hopefully mitigate some of this. But these are costly in terms of coordination and in scientist time. And even these good practices, I think, could be better guided if we had well-established data quality metrics as something of a benchmark of our EEG data to say, are we recording this well or not so well? With Steve Luck, we were thinking, what is it that a good metric should do? What are the desirable and necessary properties? We want something that's going to be robust and consistent and sensitive to those things that are noise that's likely to be present. We want the metrics that we're producing to be interpretable and transparent, and hopefully very easily usable in people's typical analysis pipeline. But it's also necessary that they must be mathematically principled. I think it's the case that many people agree that that such a thing is an issue, but they think in their lab they're addressing it already. Perhaps if you already describe your own methods, and you know that your practice has been going okay so far, it feels like an internal replication. But I think I would say for a new data quality metric, just reporting your methods is not going to be sufficient to give people a sense of what your data quality is. I think it is good practice when plotting ERPs, as we've seen already today, to show the standard error across each time point. But this spread, just the standard error alone, it doesn't say whether your data quality is good or bad. It could be that your true effect does have some amount of spread. So I don't want things that just punish big effects. And I think it also makes sense that the metrics we use should not be blind to the experimental target. Something that is sufficient for an N for 100 might not be sufficient for examining a feedback-related negativity. It might be that we need different signal to noise ratios to establish these things well, and so different environmental situations. An example I think I can share with this is in the ERP Core exemplar experiments that we have shared recently. We had a kind of reference P300 study in this, where along the time period of 300 to 500 milliseconds, something that's frequently done is measuring the mean amplitude within this window. And if you're examining a paper and it reports the P3 as this figure here, is the task of the reader and perhaps the reviewer of this paper to figure out, is this a good ERP? Is this a good study? Is this good data? And from this alone, this is difficult to figure out. But as I think you guys would agree, if you look at the single trials, you can get something of the representativeness of this ERP. There's something in the spread here where each single trial I've shown in a different color, where these 12 epochs average together to produce this ERP. The time period that you're interested in can go into this measure. What is it that we can do to have this put into one data quality metric? And what we're proposing is standardized measurement error, which we define here as taking the score in the time period where we have the standard deviation of this score of interest at this time period divided by the square root of the number of valid epochs here. So if there's an epoch that's getting rejected, this is not included in this. If there's another epoch that you can have in here that's typical of the same, then the SME is not going to be changing too much. And we suggest that if we had extensive use of this and people were also reporting this, this would help researchers be better calibrated at assessing the data quality. But we do not take it to be that people have to manually calculate this. We have also written code that will calculate this on EEG epochs. And we include this in our ERP Lab toolbox. So if you're familiar with EEG Lab, there is the ERP Lab toolbox that can be installed with this, where if you have a series of epochs and you run our ERP Lab averager, now it will have this data quality quantification option, which is on by default. And custom parameters can be set, but by default, this will calculate this every 100 milliseconds relative to your stimulus onset. So for continuing the P300 example, it will show you for each bin. Take it here where we have 3 electrodes for the sake of simplicity. We have the frequent bin on top, the rare bin below. Each 100 millisecond period has the SME calculated within this. And here we can see, as might be expected, that the frequent bin has a lower SME than the rare bin, which has fewer trials and will have more change within it. The example I've pointed to so far here has been of the mean amplitude, which is something that many people report, but can have some issues. But I also want to stress that this SME can be calculated on other measures as well. So if somebody, I think as Colin mentioned in the first talk here, just measuring peaks can be quite problematic. But another measure that people often report is the half peak latency. So the time at which half the peak has been reached in the ERP. And measures like this, you can also get SME, but using bootstrapped resampling. So in a situation where you have frequent and rare trials, we would create many iterations and calculate the score on each of these iterations, and then examine the distribution of this to calculate the SME. And I also include some extra code in the new version of ERP Lab to calculate this in 2 or 3 lines. where your average, where your epoch EEG would be turned into perhaps 1,000 bootstrapped ERP sets, and we might take the measure of each of those and then save the SME of each of these, which could be reported in a paper. And I also want to stress that the code is available for this, and we have a preprint of this standardized measurement error paper available as well. And of course, the code and release and the binary release for ERPLab is available on GitHub as well. And thank you all. Thank you, Neuromatch.
Awesome. Yeah, fantastic talk, Andrew. So we have several questions. We'll see how quickly we can get to them. So in the Q&A, someone asks, if I understand correctly, SME is calculated at the individual subject level. How do you combine them for group statistics?
So these definitely can be combined together for group stats. We've found that in order to take SME and relate this to effect size and feature, it makes more sense to average together subjects using root mean squared combination. And at the point of doing the group averaging in ERPLab, this is automatically combined in RMS.
Awesome. So Colin has a question as well. So he's asking, have you or do you plan to compute SME for every panel of very common ERPs, like from published data sets? Because that would be useful.
Absolutely, yes. So we have, thankfully, the ERP Core experiments, which we hope to be exemplars for many different commonly reported ERPs. So that has a P300, it has N400. I think it does not have feedback related negativity, but we got a few in there. And what we hope to do is release the information that we have of the values on this. We're not taking these as targets, as in, your experiment must be this good if you want to report it. But we want to have this as a kind of zoo of existing values, of typical values, rather than values to optimize towards.
Makes sense.
But what we hope to do is have an option in ERPLab where you could compare your current study to existing studies to see if your study is doing okay, or if there's things you need to do to improve.
Great. And then Adam asks, have you thought about integrating this into the BIDS specification for EEG data? Because it seems like it'd be useful for reproducible science.
That would be useful, yes. So we've had a few papers recently that we've tried to encourage using EEG bids as a default way for arranging your data. We've also used this for the ERP Core experiments. We've ensured that this is specified in a bids compatible way. So far, we have reported the SME in the derivatives folder for bids and just kind of pointed people to that. But I think as they've done in fMRI, it might be useful to have explicit fields in bids that are at least encouraged for some reporting of the data quality in our shared studies. I think there might be such a thing for baseline values, but I think it would make sense to have more things in there as well. But so far, I've only put that in the derivatives folder for bids.
Great. Well, yeah, thank you all three of our speakers again.